Morning, y'all. This is Mr. Walker here coming to you with our notes for today. This is a 2-for-1 special. We got classifying triangles by both their angles and their side lengths. We also got two theorems that are going to be popping up at us with the exterior angle theorem and the sum theorem. So let's get this rocking now. Alright, first classifying triangles by their angle measures. We got acute angles, right angles, and obtuse. They could be in there, so let's go through and get into those criteria. First, with acute triangles, those are triangles with three acute angles. So all three of the angles inside of this triangle are all less than 90, but are larger than 0. Next one we got for a right triangle, that is a triangle with one right angle. So that means that you'll see at least one right angle, just like shown here. That'll usually be indicated by the box. You won't have to go through and thug it out with this type of thing. Alright, it'll be pretty obvious. Now for an obtuse triangle, it has one obtuse angle. So for this, it's safe to assume that if you see an obtuse angle like this in a triangle, that is an obtuse angle. Okay? Now usually we'll give you some other stuff to indicate it if it's not, but it's safe to say that this will be obtuse enough. Alright, getting into the first of our theorems. If you look at the three angles inside of a triangle, 1, 2, and 3 right here. If you were to separate these from the triangle and put them all together, they actually form a straight line like this. So, this goes into our first theorem, the sum theorem. All of our angles, the sum of the measures of the angles in a triangle is 180 degrees. So, no matter what the triangle is, all three of the angles will add up to 180, no matter what. So if you ever have to go through and find a missing angle, that's going to be the way that you deal with it. If you have to set up anything to figure out an X, that's one of the ways that you can go through and set it up. Alright, with that in mind, we got two triangles here, triangle A and triangle B. How will we classify these? First, we look at the angles that are inside of the triangles. If we got three angles, we can figure out what kind of angles they are and what type of triangle this is. So for A here, we got a 33, we got a 57, and we got a right angle box. That means that this is a right angle, aka 90 degrees, which means we got ourselves a right triangle. Now for our other one, we have two angles here, 45 and 35, but we need to figure out what this top one is. Based off of the sum theorem, I know that all three of the angles add up to 180. So to figure out what this angle is, right up here, we go through and take 180 and we subtract our two angles that we have here, 45 and 35. So if I add 45 and 35, that's an 80 degrees. Sorry about that. So that means that this is going to be 100. So the top part here, this top angle is 100 degree angle. Oh Lord, that is a rough looking 0. Let me go through and fix it. There we go. So that is 100. Since this top one's 100, 100 is an obtuse angle, which makes this an obtuse triangle. Boom, bam, pop. Alright. Next one that we got a new theorem coming at us, so let's get into it. With our triangles, if we to look at two of the angles, in this case 1 and 2, and let's say we had one of our sides that extends off like how we do right over here by 3. What we have here is a case where the two inside angles, 1 and 2, when we break those off, those end up being the same size as this outside exterior angle right here. So this brings us into our second theorem, the exterior angle theorem. The measure of each exterior angle in a triangle equals the sum of its two non-adjacent interior angles. So non-adjacent, that means that not next to. So the two angles that are not next to the exterior angle add up to our exterior one. So to find angle 4, it's what angle 1 is plus angle 2. And that's what you got to do. So you're either dealing with three angles adding up to 180, or you're dealing with two inside angles adding up to an outside one for these first two theorems. All right, people, we got a couple of examples here. We got the top two, and we got these bottom two. They're either going to be the exterior angle theorem or the sum theorem. I'm going to give you a minute so you can try it, pause it, and then come back. All right, hopefully you went through and paused it. If you didn't, it's cool. Let's get into this. We got for triangles here that we got to go through and find out our x, and then we got to classify the triangle by its angle measure, which means that if we find the x, we got to plug it back in there. All right, first one that we got here for A, we got 54, x plus 74, and 53. These three are all inside the triangle, so that means we are going to be utilizing our sum theorem, which is adding all these up and subtracting them from 180 so we can figure out what this x is. So I know 54, 53, and 74. When I add these up, this gets me, I think, 181. So if I got 181, I will subtract that from 180, which would give me x equals -1. Now that we have our x here, we got to figure out what this missing angle is so we can classify this. There's two ways you can do this. You can either go through and plug this back into the x and figure out what the angle is, or if you got two of the angles that you already know, you could just subtract those two from 180 and that'll give you what this last one is. But put a -1 in, it's pretty easy. So -1 into this makes this a 73-degree angle, which is an acute angle along with these two, which makes this an acute triangle. Easy peasy lemon squeezy. Alright, next one's getting a little bit different, so you got to think outside of the box. You might think the first time you look at this that this is the exterior angle theorem, but this little shape here, since it has two lines, this isn't exactly the exterior angle. See, this right here for D, that's an exterior angle because we only got that one line coming off and this is right outside touching the triangle. Since this right here is in the vertex, this is actually a vertical angle with our inside angle in the triangle. So that means that we are going to be using the sum theorem. So that means you're adding 80, 4x, x plus 17, x, and 23. When you go through and do that, I got x and x, that's 5x. I got, let's see, that's 97 plus that, so this is 120 plus 5x. Let's go through and write that down just so we can keep track of that, okay? All this gets you 120 plus 5x equals 180. Now I know this, when I go through and subtract the 120, that gives me 5x equals 60. And then if I divide both sides by 5, that means x has got to be 12. Now, if I go through and plug 12 back into both of these, 12 into this gets me a total of, let's see, that is 35. And then down here, this gets me, let's see, 12 plus that, this would be 65, I believe. Let me just double check, 48, yeah, that's 65, which makes this an acute triangle. Okay, got a little bit scary there. I thought I was going to be bad with my math. Boom. All right, next one we got here. C is a little bit easier because they automatically give you this 90-degree angle right here. So that means that automatically, because this box is here, this is a 90-degree angle, which makes this a right triangle. But we still got to figure out what x is. So let's figure it out. All our angles are inside the triangle. So that means that I take 90 plus x plus 37 plus x plus 67. And that adds up to 180. Once I go through and combine my like terms and subtract, I end up getting an x being -7. Since I see the right angles there, it's automatically a right triangle. We don't got to go that far to think of it. All right. Now for our last one, we have two angles inside the triangle, one outside. So since we have those two inside and they're not touching that outside one, that's the exterior angle theorem we're going to use. So we got x plus 100 equals 34 plus 60. So I got to take 34 plus 60. That gets me 94. and then I'm going to subtract that 100 to the other side because we got to get x by itself, which gives us x equaling -6. Now that's -6, and I know that these two angles inside are both acute. That's acute, that's acute. If I put that x back in it, this makes this an obtuse angle, which means that this inside one has to be acute, which makes this also an acute triangle. Boom. Alright folks, let's figure out these bottom two questions. Now this is a mix of both of our theorems that we've done, so we got to take our time. We'll be able to go through and solve it. Alright, first off on A, we got two triangles here with these angles here, and there's our x over here with 75. We're going to first figure out some information about this triangle. So I know that these two angles and this blank one add up to 180. So if I take 180 and subtract 56 and 39, I get 85, which is this angle right here. Now that I got this, I can use what I know about straight lines, which lets me know that 54 and 85, and whatever this blank one is, all make up a straight line. So I'm going to take 180 again and subtract 85 and 54 to get 41, which is this angle right here. Now once I got those, I can then subtract 41 and 75 from 180, and that'll give me x equaling 64, which is this angle here. Now, all of these that we did here, this is all us using the sum theorem and the fact that angles on a straight line add up to 180. But you could also use the exterior angle theorem to say that 54 and 85 is equal to 75 and x. But there's more than one way for you to do things, of course. Alright, over on B, we got a little more complicated one. So, we got these angles here, 56, 97, this blank one. I know that this big angle here that both of these two are in is 90, and I know that this is 32. So let's go through on a journey. First off, let's figure out what this smaller part of this angle is. So I know 180 subtracting 97 and 56 gets me this 27-degree angle right here. Now that I have this, I know that 27 is inside of this 90-degree angle box. So what I could do is I could take 90 and subtract 27 to get me 63, which is this right here. Now, 63 and 32 are both inside this triangle, and x is outside of the triangle, which makes this an exterior angle. So we can use the exterior angle theorem. So if I take 63 plus 32, that'll give me 95, which means x is 95. All right, so far so good. All right, people, let's get into our next round of notes for this. Classifying based off of sides can give you a little bit of insight for the angle measures, so let's keep those things in mind that we just talked about as we go through this. For an isosceles triangle, this is a triangle with two congruent sides. So we'll have two sides here, these sides with the same hash marks, those are the same. As we go through and deal more with triangles, you'll notice that the sides that are either the same size, like if you have one side that's bigger than another side, that means that the angle that's across from there is also bigger than the angle that's across from the other side. In this case, because we have two sides here that are the same, that means we also have two angles here that'll be the same. So this side right here and this angle, and this side and this angle are both also the same, just like how these sides here are the same. With equilateral triangles have three congruent sides, which means that all three of these sides with the same marks, they're also the same. Likewise, the angles here in the triangle are all also the same. So if all three of these angles are the same and they all add up to 180, these guys are all 60-degree angles. I'll go through and write that in there. But this is the only one that has a special property just like this where all the angles are automatically this because it's an equilateral triangle. Just keep that in mind. If you see equilateral, all the angles are also the same. Now for our final one, a scalene triangle has no congruent sides. And if it has no congruent sides, the angles also are non-congruent. So all three of these sides, they're different. All three of the angles, they're also different. All right, keeping this in mind, we got some angles and some side lengths that we can go through and use to classify these types of triangles. So we're going to classify based off of the angle measure and the side lengths. Over on letter A, they give me three 60-degree angles. If all three of the angles are the same, all three of the sides are the same. So this will be an acute equilateral triangle. Over on B, I give you three side lengths, 3, 4, and 5. All three of the sides are different. That's good to know. But I only give you two of the angles. So you're going to have to actually go through and use a little bit of know-how to figure out what that third angle is. Now I know if all three of the angles add up to the 180, that means that I would just take 180 and I'll subtract 37 and 53. Now I know 37 and 53 give me 90, so 180 minus 90 gives me 90, which means this is going to have a 90-degree angle also. This means this is a right scalene triangle. All right, over on C now, I see that I got two sides that are the same, which are going to let us know that this is isosceles. Now, the way that these angles look, it doesn't look like any of these are right angles because I see no boxes, and none of these angles look like they're obtuse, so I think it's safe to say that this is an acute isosceles triangle. Now, for our last one, not last one, this second one that's in the middle, we got three sides here. There's one mark on one, two marks on one of the other sides, and three marks on the other side. These markings all tell you that the sides are different lengths. And I can see that this big angle here towards the bottom is an obtuse angle. I think it's safe to assume that that's obtuse. So this would make this an obtuse I meant to say obtuse scalene. Let's go through and edit that. Scalene. Perfect. Scalene. All right, now for letter E, I give you this 45-degree angle and this 90-degree angle. So you got to figure out what this angle is before we can go further. So I know 180 minus 90 gets me 90. And 90 minus 45 is 45. Which means that this angle here is also 45 degrees. Since I have two angles that are the same, the sides across from them are also going to be the same. So this is going to be a right isosceles triangle. And then for our final one, we see that there are three sides here, 3.3, not 3.3, 4.3, 4.3, and 4.3. Since all of these are the same size, you can assume that the angles will also be the same size as well, which would make this an acute equilateral triangle. All right. Now, over on the side and on the bottom, on the side, you want to go through and sketch the triangle as described. If no triangle can be drawn, write not possible. And then just go through and mark the sketch appropriately. So you don't have to go through and measure it out with a full ruler and give me lengths like that. You can use hash marks like how we used for some of the examples that we just saw. So pause it, give it a try, and then let's see what it is. All right, hopefully you went through and paused it. I appreciate you if you did. Let's go through and take a look at these. First one, A, is not possible. For something to be equilateral, that means all three of the angles have to be the same. So you can't have an obtuse angle on all three of the angles on a triangle. Won't work. For the next one, we got an acute isosceles. We've seen a couple of examples like that. We just got to make sure that we mark it. Next, acute equilateral. We just got to go through, mark us a triangle, three sides that look the same, we give it the same mark. And then if it's a right scaling, go ahead, write that right angle box, and then mark each of the sides a different length. Now on the bottom, you got a couple of triangles I want you to go through and try to measure out and classify. I'm going to leave you to go through and check that out on your own. If you got any questions, feel free to hit me up in the comments or ask me in class. Thanks for watching. Have a good day.